Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics, Paper 5, Probability and Statistics 1 for October-November 2022, and the code is 9709/53. Okay, so let's move on to question 1. Now, 50 values of the variable x are summarized by summation x minus 20 equals to 35. And summation x squared is 25036. Now find the variance of these 50 values. Okay, so from summation x minus 20 is 35, we know that this is going to be summation x minus 20 of 50. Alright, because 50 values. So you minus this for minus 20 for 50 times. Then it will be 35. So at last, summation x is 35 plus 1000. So it is 1035 for the summation x. And now you are given summation x squared. Therefore, we can calculate the variance x. So now the variance x equals to summation x squared over n minus mean squared. So the mean squared is basically summation x, okay, or squared of summation x over n. This is our mean squared. So now replace all the values. 25036 over 50 minus square of summation x, so 1035 over 50, and you will be getting 72.23. Okay, so for the variance, or probably you can just write 72.2, correct to 3 significant figures. So this is actually the exact value, right? So based on the question, you need to leave non-exact value, correct to 3 significant figures. So since we get the exact value here, so better to just leave your answer in 72.23 because that is the exact value. Otherwise, you have to round up to 3 significant figures. So that's all for number 1. Okay, now for question 2. In a large college, 32% of the students have blue eyes. A random sample of 80 students is chosen. Use an approximation to find the probability that fewer than 20 of these students have blue eyes. So now your sample size is 80, but the students is discrete random variable. So initially it was binomial, but since your n is 80, therefore we use normal approximation to binomial. Okay, so I will write x is binomial 80, 0.32. Then from here, I will convert it to normal distribution. So now, I need to count what is my NP. NP is 80 times 0.32. You will get 25.6. And then the NPQ will be 25.6 times, this is your P, 0.32. So the Q is 1 minus 0.32, and you will get 0.86. So at last, you will get 17.408. Alright, so now my mean is 26.5, and then my variance is 17.408. That is my new distribution. Okay, so now based on the question, you need to count probability that less than 20 of the students have blue eyes. So x less than 20. Okay, but then since you have approximate the binomial to normal, therefore we need to consider the continuity correction. So let's say here is 20. But since x less than 20 means that I will accept 19, 18, and onwards, right? So then we are allowed to plus 0.5 and minus 0.5 from 20. So when I plus 0.5, it will be 20.5. Minus 0.5 from 20, it becomes 19.5. So now I will write PW less than. Alright, you must follow the sign, the inequality sign. So obviously, from this number line, we know that we have to accept less than 19.5, okay, to include the ticks. So it is 19.5. And then now we standardize it. So when you standardize it, you're actually minusing 25.6 from 19.5. Then over the standard deviation. So this 17.408 is actually the variance. So now to get the standard deviation, take a square root of the variance. Then you will get pz less than negative 1.462. Now, when you get pz less than negative 1.642, then now we need to sketch a graph because the negative z is not allowed in the table. Right, it is not available in the table, I would say. It is not available. So now I will just draw out the region. Let's say here is negative 1.462. Okay, when it is less, that means that the region is towards left hand side. This is the actual region that we need to count. But then since the value of the z is negative, therefore we have to flip it to be positive. Once we flip, the region becomes the green color. So in order to get the green region, it will be total properties 1 minus pz less than 1.462. That will be the green region that we need to count, which is also the blue region. So here becomes 1 minus pz less than 1.462. And now you get the value from the table. Pz less than 1.462 is basically 0.9283. So at last, you will be getting 0.0717. So that is the solution for question 2. Okay, so now question 3. The times t minutes taken to complete a walking challenge by 250 members of a club are summarized in the table. So now your table shows the upper boundaries. Okay, t less equals to 20, less equals to 30, until less equals to 60. And then the cumulative frequency as well. So 32 until 250, because total is 250 members. Now A, draw a cumulative frequency graph. So for cumulative frequency graph, our vertical axis is the cumulative frequency and the horizontal axis is the upper boundaries. So all these are the upper boundaries. Means that now we just need to draw according to this table. Okay, so horizontal axis will be up to 60. Vertical axis will be up to 250. Alright, so let's say here, so my horizontal axis is basically the time taken. So I need to label up to 60. Means now I let this be 10, 20, 30, 40, 50, 60. Then here is the time taken. T in minutes, or T minutes. Okay, this is my 50. Then the vertical axis is up to 250. So 250, let me check first. Okay, 250, so here probably here is 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. That means this is my cumulative frequency. Okay, so you use the ruler to draw the vertical axis. Okay, so now the first point is at t equals to 20, the vertical axis is 32, so 20, 32. So 20 is over here, 32, which means each square is 4. Okay, so 4 means that this is 24, 28, 32. Then the next value is 66, and then 30, 30, 66. So here is 30, 60, this is 64, 66 is in the middle. Right? Then after that, 35 is 112. 35, 35 here, 112. So here is 1, 100, 104, 108, 112 is here. Then after that, 40, 178. So 40, 178 means that it will be 2 from the 180. Right? Then when t is 60, it is 250. 250. Where is my 60 first? My 60 is here. 250. Okay, 244, 248 is in the middle. Alright, so now you need to join all these points. So draw a smooth curve. Now, since this is cumulative frequency graph, we will start from 0. So when 0, it will be 0 here. Okay, so please draw a smooth curve. I will try my best to do it. Okay, so it's not so smooth. Right, so please draw a smooth graph. My graph is not so smooth. Okay, so now done the graph. Okay, now use your graph to estimate 60th percentile of the data. So 60th percentile is basically P60. Okay, I will write P60 is 60 over 100 times the total data. Alright, so from here, when you simplify, it is 150. Data number 150. So now you need to get the answer from the graph. So what to do is draw the 150, which is here. Okay, use the ruler to estimate from the graph. So from here I get 38. Right? So this is my 150. So therefore P60 from graph, P60 is 38. Okay, so 38 minutes. Alright, so that's the solution for B. Okay, now C. It is given that an estimate for the mean time to complete the challenge by these 50 members is 34.4 minutes. Alright, that means this is T bar 34.4. Now calculate and estimate for the standard deviation for the times taken to complete the challenge by all these members. So now, okay, our formula for the standard deviation is square root of summation fm square over summation f minus the mean square. This is the formula. But then now when you refer to the table, okay, you are given the cumulative frequency, but our small f is actually the frequency. Means now I need to count the frequencies and also the midpoints. Okay, so now I will copy this table to get the calculation first. So I will do it here. And then I need to add 2 more calculations. This will be my t values, then the cumulative frequency, and midpoints. Okay, maybe I will just do it over here, better. Okay, so I will copy the whole table here, right? Oh, I will just write less equals to. Then here is 32. Less equals to 30. 66. Less equals to 35 is 112. Okay, then less equals to 40, 50, 60, 178, 228, and 250. So 40, 50, 60. So I get 178, 228, and 250. So now for my f, it is the frequency. So rewrite. So now for the second frequency, it is 66 minus 32. So when you minus, you will get 34. Okay, then 112 minus 66, you will get 46. 178 minus 112, it will be 66. 228 minus 178, it will be 50. And then 250 minus 228, it will be 22. Okay, so to get the midpoints, so this first class is basically 0 to 20. So now the midpoint is summation of these two values and divided by 2, which is the average. Alright, it is a midpoint. So summation then divided by 2. So that means you will be getting 10. So for the next one, we will count from 20 to 30. So it means that you get the midpoint of these two. So 20 and 30, the midpoint is 25. How to count the 25? 20 plus 30, then divided by 2. And same for this. The next one is actually 30 to 35. Alright, so when you get the total, it is 65. Then divided by 2, it will be 32.5. And then here is 35 to 40. So the midpoint is at 37.5. And then the next class is 40 to 50. So the midpoint is at 45. And then the last class is basically 50 to 60. So the midpoint is at 55. Okay, so now I will substitute into this formula for the calculation. So it will be summation, or square root first. Summation fm squared means you square the m before you multiply by f. So now I square the m and multiply by the f. So 10 squared, 32, plus 25 squared, 34, plus 32 squared, 32.5 squared, times by 46, plus 37.5 squared, times 66, plus 45 squared, times 50, plus 55 squared, times 22, and then all this over the total. Total is 250, minus the mean squared. Okay, the mean is 34.4. So I need to square this. Alright, so this is the standard deviation formula. So now, when you count the total here, okay, or you just count all one shot, so it will be square root of 151.24. Or otherwise, you can just count what is the numerator answer first. So from here, at last, you will be getting 12.3. Okay, so this is the solution of this question. Okay, now question 4. 3 fair 4-sided spinners each have sides labeled 1, 2, 3, 4. The spinners are spun at the same time and the number of the side on which each spinner lands is recorded. The random variable x denotes the highest number recorded. Okay, so basically there are 3 fair spinners. Alright, each spinner has 4 sides. So since it is fair, means that the probability of landing on each side will be the same, which is probability of each will be 1 over 4. Okay, so now the x is the highest number recorded when you spin 3 spinners. So now show that px equals to 2 equals to 7 over 64. So first of all, I need to write down the outcomes to get x equals to 2, which means the highest score is 2. Okay, so this may refer to 1, 1, 2. So first 2 spinners show 1 and the last spinner show 2, means lands on 2. And then it could be the 2, you can just consider the arrangements. So it will be 1, 2, 1. It could be 2, 1, 1. Alright, and now I will consider 1, 2, 2. There are 2 times of 2. And then 2, 1, 2. And then 2, 2, 1. Okay, it could be all 3 also show lands on number 2. So these are the outcomes. So from here we have 7 outcomes. Alright, so now px equals to 2. Now remember, since you are given fair spinners, so it means that each probability is 1 over 4. So to get 1 is 1 over 4. The second one is also 1 over 4. The number 2 is also 1 over 4. So it means that each outcome is basically having this probability. And there are 7 outcomes, each of them with the same probabilities. Therefore, I just times 7. Alright, so that's why you are getting 7 over 64. Okay, so this is how we show the probability of x equals to 2 equals to 7 over 64. You need to list down the outcomes. Right? Now B, complete the probability distribution table for x. So when x equals to 1. So when x equals to 1 now, right, I will say that x equals to 1. That means this is referring to 1, 1, 1. All shows 1. So px equals to 1, it will be 1 over 4 for each. And same probabilities, therefore 1 over 64. So I will just copy back. So here 1. Oh, sorry, I need to count the other one first, okay, before I complete the table. So now, when px equals to 1 done already, then given 2 probabilities, you can find the last probability. So px equals to 4 is basically 1 minus all the 3 probabilities. So 1 over 64 plus 7 over 64 plus 19 over 64. So at last, you will be getting 37 over 64. Okay, so now I can just copy back the table. 1 is 1 over 64. And 2 given 7 over 64. When it's 3, 19 over 64. And when it is 4, I get 37 over 64. So this is my probability distribution table. Okay. Now, question C. On another occasion, one of the four-sided spinners is spun repeatedly, so only one, okay, until a tree is obtained. The variable y is the number of spins required to obtain a tree. So that means you need to get a tree. You spin until you get a tree. That means this is geometric distribution. Alright, so when py equals to 6 means that you need to spin 6 times, and the last, the 6 the 6 results will be the 3, okay? When you spin the 6 times, the time number 6, the spinner will land on 3. That's the meaning of this py equals to 6. So that means, okay, I will draw 6 lines. 1, 2, 3, 4, 5, 6. This is to get number 3. Then all these 5 are not number 3. Okay? So now, to get number 3, it is 1 over 4. Alright, the property is 1 over 4. So when not 3 means 1 minus P3 is 1 over 4. So P not 3 means it is 1 minus P3. So which is 1 minus 1 over 4, I'll get 3 over 4. So now since it is geometric, means that Py equals to 6 equals to, okay, I have 5 here. There are 5. So 5 not 3 means that it will be 3 over 4 degree 5 multiplied by the last one is a 3 and the probability is 1 over 4. Okay, so from here you will get 243 over 4096. So that's the solution of this question. Okay, now D. Find Py more than 4. Now don't forget, this is geometric progression. So you have to continue until you get the success, the first success. So Py greater than 4. If you remember, there is a formula for the geometric distribution. So I will say that Py greater than 4 is 1 minus Py less equals to 4. Okay, now for geometric distribution, okay, geometric distribution. So when px less equals to small x, it will be 1 minus q power x, where the q is a probability of failure. So that's why I changed to this form. I changed to y less equals to, so it will be the same, then I can apply the formula. So this is the first way to do it. So 1 minus, so py less equals to 4, when you compare, your x is 4, right? My y has been changed to y, my x has been changed to y, then it will be 1 minus q degree 4. So now when you open the bracket, it's 1 minus 1 plus q degree 4, which is my q degree 4. So what is my q? The q is not getting 3. Okay? Not getting 3 is 3 over 4. Therefore, the answer is 81 over 256. This is the working if you memorize the form, if you can recall the formula. But what if you can't recall this formula in the exam? Okay, so, or you may use another method. Or Py greater than 4, it will be 1 minus Py less equals to 4. So when y less equals to 4, now we count each of them. So you must have spun 1 time, okay, to get the first success, or the second time, or the third time to get the first success, or the fourth time to get the first success. So if the Py equals to 4 means that first time you already got the success, means that it is 1 over 4, first time. Or Py equals to 2 means that second time only you got the success, means that first time is failure. So failure is 3 over 4, then followed by first time of success. When y equals to 3 means that first two times are failures. So 3 over 4 degree 2, and then 1 over 4 degree 1. That is the success. Plus y equals to 4 means that first 3 times are failures. So 3 over 4 to the power 3, then 1 over 4. right? So when you use this, the brackets will be 175 over 256. So when you minus this value from 1, you will be getting the same value as the blue color, as the previous method, which is 81 over 256. So you may leave your answer in fraction or correct to 3 significant figures. Alright, so it's very useful when you memorize this formula. It is mainly for geometric distribution. Alright, so we have done this part. Question 5. Company A produces bags of sugar, and inspector finds that on average 10% of the bags are underweight. 10 of the bags are chosen at random. Find the probability that fewer than 3 of these bags are underweight. So from here, the bags will be discrete. Okay, therefore, this is binomial. Okay, so your x is binomial, n is 10, 0.1, which is 10% are underweight. So now less than 3. So px less than 3, it will be px equals to 0 until 2. So you consider all these probabilities. Alright, so now if x equals to 0 means that no success, means all failures. So probability of success is 0.1, means that probability of failure is 0.9, all success, all failures. So 10 failures. Then plus px equals to 1 means that out of 10, 1 success. So 0.1 degree 1 followed by 0.9 degree 9. Plus px equals to 2 means that out of 10, 2 successes. So 0.1 degree 2, then 0.9 degree 8. Alright, so when you count all this, it will be 0.9298. And now I round up to 3 significant figures, it will be 0.930. Alright, now the weights of the bags of sugar produced by company B are normally distributed with mean 1.04 kilograms and standard deviation 0.06 kilograms. So now it's the weights. Just now was number of bags, right? So number of bags. So I will not use the x anymore because my x is representing number of bags. So now find the probability that a chosen bag produced by company B weighs more than 1.11 kilograms. So now I will write y to represent the weights of the bags. So y is normally distributed, 1.04 mean, and the standard deviation 0.06. Now we need to write down square of this because it is the variance. And now to count the probability that the weights are more than 1.11 kg, so means that y more than 1.11. Okay, the weight is more than because a bag. Now we standardize this, so it will be p z more than 1.11 minus the mean 1.04 over standard deviation 0.06. Then when you count this value, the value is 1.167. Now draw the graph. Okay, now my z value is positive, so it is on the right hand side, and then the region is towards the upper tail because it's more than. So from here, obviously it is 1 minus pz less than 1.167 because the probability of z less than 1.167 is available in the table. Now from table, the probability is going to be 8784. So when you simplify, this will be 0.1216, and when you round up to 3 significant figures, it's going to be 0.122. Okay, so we have solved B. Now, 81% of the bags of sugar produced by B, by the company, weighs less than W kg. So find the value of W. So now I will rewrite my Y. I don't want to write my X because my X is the number of bags. My Y is the weight. So it will be 1.04, then 0.06 squared. Now I mentioned that it is less than W kg. So P Y less than W is 81%, so 0.81. So, and then now we need to find what is the W value. So, first of all, standardize it. W minus 1.04 over standard deviation is 0.06. Then the probability is given 0.81. Okay, so now, once you have standardized it, we need to sketch a graph. So now, if you have no idea where is this line, okay, where is this Z value, this is going to be Z value. So you can just check when it is less, because Z less than. So when it is less than 0, this probability is only 0.5. Right? Because it divides equally for the graph. But now you are given 0.81. That means the line should be on the right side, so that we will have bigger region. Then the probability will be bigger. Okay, so here is W minus 1.04 over 0.06, and this probability is 0.81. So this is how we decide where is the Z value. Okay, so now from here, since the Z value, which is W minus 1.04 over 0.06, is on the right hand side of 0, that means it's positive. And then now the region 0.81 is towards the left hand side. That means you can just read the value from the table. Okay, from table, PZ less than 0.878. When you refer to table, you are getting this value from the table. It is 0.81. That is the probability. Okay, so now you compare these two equations. So obviously your W minus 1.04 over 0.06 is 0.878. So now your W is move up this and then move the negative 1.04 to the other side. So you will get 0.06 times 0.878 plus 1.04. Okay, so we'll calculate all this. It will be 1.09268. Then we can just round up the answer, 1.09. Okay, so this is the solution. Okay, now question 6. Find a number of different arrangements of the 9 letters in the word activated. So activated, there are 9 letters. Out of these 9 letters, I have 2 A's and then I have 2 T. The rest, I have C, I, V, T, D. All these are not repeated. So now, to get the arrangements of 9 letters whereby there are 2 A's and 2 T, so I will write number of arrangements equals to 9 factorial over 2 factorial from the A and 2 factorial for the T. So it will be 90720. Okay, now B. Find the number of different arrangements, again arrangements, of the 9 letters in the word activated in which there are at least 5 letters between the 2 A's. So now, okay, I may have A, then 5 letters, 1, 2, 3, 4, 5, another A. So initially we have 9 letters, so 5 in the middle, then plus 2a's, so means 7. So now I have another 2. So these 2 can be at the back, in the front, or one each at the end. Alright, so here I may get A, then A, after that front, and maybe 1 at the front, 1 in the front, and then 1 at the back. 1, 2, 3, 4, 5. Alright, so these are the cases when it is exactly 5, but now it's measured at least 5. So at least 5, this is 5. So at least 5, maybe 6. So I may draw A, then 1, 2, 3, 4, 5, 6. So 6 in the middle, I mean 6, there are 6 in between the A, 2A's. So 6 plus 2A's means 8, means I have another 1. This one can be at the back or can be in front. Okay, so it could be 7, alright, so or 7. So it means that there are 7 letters in between. So A, 1, 2, 3, 4, 5, 6, 7. So we have to consider all these 3 cases right now. So for the first case, second case, third case. Right? So for first case, the number of arrangements will be, now remember, here we have 2A's and 2T. So which means, here don't forget, out of, right, so total 9, you minus 2, that means here still have 7 in total. Here 5, here 2. So out of this 7, right, I still have 2T. So I don't bother where are the 2T's. So I know that I'm going to arrange 7 letters, but 2 are T's. Okay, so when you arrange this, it will be 7 factorial over 2 factorial. And then I have 3 cases. So therefore I times 3. Alright, so now for the second, it will be, again, here I have 7 letters. Alright, so out of 7 I have 2T. So it will be 7 factorial over 2 factorial. Now I have 2 cases here. That means I times 2. So when you count, the first one is going to be 7560. Then here is going to be 5040. Alright. Now for the third case, so here it is out of 7 letters, I have 2 T's. So which means the arrangement is going to be 7 factorial over 2 factorial. Then you will get 2520. Alright, so now the total arrangements is just to add up these 3 cases. Then at last, you will get 15120. Okay, so now 5 letters are selected at random from the 9 letters in the word activated. Find the probability that the selection, okay, probability that selection does not contain more T than A. Does not contain more T than A means, okay, does not contain more T's than A's, which means this is 1 minus P contain more T's than A's. Alright, that is a complement. So now I need to count what is the condition, what are the conditions for getting more T than A. So from here, Alright, more T than A. I use another color. So now you need to choose 5. Alright, and we have 2 A's and 2 T. So if more T's than A means that probably I get 1 T, then no A's. Okay, so I get 2 T's and no A's. I get 2 T's and 1 A. Okay, remember this is probability of selection. Now, for the first case, if you get 1 T and 3 A's, so remember this T, because you have 2 T's, so the probability for the first one is going to be, okay, so 1 minus, so the first one is basically from 2T you need to choose 1T, so therefore 2 choose 1. And where to get these 3? These 3 you must exclude T and A, therefore you have to choose from the remaining 5. Okay, because at first you have 9, so you minus this 4, you still have 5. Not A and not T. Alright, so from this 5 you need to choose 3. Therefore 5 choose 3. Alright, or is plus. I need to get 2T. So 2T means 2T, I choose 2. And then I have 5 non-A and non-T. So I have to choose another 2 from this 5. So 5 choose 2. Okay, plus 2 choose 2, 2T. And the A, there are 2 A's. I need to choose 1. So 2 choose 1. And the 5, I choose 1. The remaining 5, I choose 1. Okay, so all these are the selections over. Since we are counting probabilities, so you must divide by the NS. So the NS is basically 9 letters, you choose 5. So in general, 9, C5. Okay, because this is the probability of selection. So now, from here, when you count, 2C1 times 5C4, oh sorry, the first one you need to choose 5. Okay, so here another one. So it should be 5C4 and not 5C3. So 5C4. Okay. Alright, so here you have one more. So it means that I need to explain again. So it's not 5C2 and so on. You should add up one more. So it should be 5C4. Okay, sorry for this. So here I need 5C3. So I need 5 letters in total. Then here is going to be 2. So now when you simplify this, it will be 10 plus 10 plus 20 over 126. Okay, so when you simplify, it will be 40 over 126. 1 minus 40 over 126. And at last, you will get 86 over 126. And simplify it to be 43 over 63. So that's the solution of this question. Right? Okay, next question, number 7. Sam and Tom are playing a game which involves a bag containing 5 white discs and 3 red discs. They take turns to remove one disc from the bag at random. Discs that are removed are not replaced into the bag. Okay, no replacement. The game ends as soon as one player has removed 2 red discs. From the back, the player wins the game. Sam removes the first disc. A. Find the probability that Tom removes a red disc on his first turn. Alright. Now basically, okay, there are 5 white, 3 red. Okay, take turns to remove 1 disc. And this is without replacement. No replacement. That means the total disc will be decreasing after the draw. So now A. Tom removes a first disc on his first turn. Okay, so now Sam removes the first disc, which means probably the S is to represent Sam. So, okay, it could be white from Sam, and then red from Tom, or red from Sam, and then red from Tom. Okay, so now white from Sam, it would be 5/8. So once you have taken 1 disc, that means the total left 7. Red will be 3. Or, okay, initially 8 discs, the red is 3, and then after taking 1 without replacement, so you still have 2 red out of 7 discs. Okay, so from here I will get this is 15/56 plus 6/56. So it is 21/56, and simplify this to be 3/8. So that's the solution for A. B. Find the probability that Tom wins the game on his second turn. Now, remember that Sam removed the first disc, alright? So it means that Sam starts first. So now, if Tom wins the game on his second turn, means that he has drawn 2 red discs, right? Means that Tom has drawn first red disc, the red disc on his first turn and also on his second turn. Then he will win the game. So now I will write P. Tom wins the game on his second turn. That means, okay, since Sam starts first, so maybe Sam get red, and then Tom get red, right? Then after that, Sam cannot take red because otherwise Sam will be the winner. So white from the Sam and red from Tom. Or maybe, okay, white from Sam, red from Tom, then red from Sam, red from Tom. Or P, white from Sam, red from Tom, white from Sam, red from Tom. Okay, so just now we have 3 red, 5 W. So now 3 red, 5 W. So initially 8, the red is 3, but after you have taken 1, left 7. So the red will reduce by 1, it will be 2. Then take the next one, 6 in the total, the white 5, and then take another one, the total becomes 5, and then the red has been taken all 3, so this is one choice, or 8. So white is 5, then the total left 7, the red color is 3, now the total left 6. So you have taken one red from the back, that means the total red now becomes 2, and then lastly red is 1 out of 5, plus white is 5 over 8, then total becomes 7, total becomes 6, total becomes 5. You can write this first. So red color is, this is the first red color, so 3. Then the white color, just now we have taken one white, so left 4. And then the second red color is taken, that means you have 2 more left. Alright, so when you count all this, it will be, so basically you can just simplify, cancel the 5, cancel the 2, and so on. So you will get 1 over 56, right? If I show the cancellation, 5 cancel, so here 6 cancel, so this is 1 over 56. Then here is going to be 5 cancel, 3 and 2 cancel with the 6, also 1 over 56, plus lastly 3 and 2 cancel with the 6, then the 4 cancel with the 8, the 5 cancel. So here if you don't want to cancel the 4, right, the 4 with the 8, then you can get the answer easily. So I won't cancel the 4 with the 8. So here is going to be 8. So I'll get 4 over 56. So at last, you are getting 6 over 56, and simplify it to be 3 over 28. So that's the probability that Tom wins the game on his second turn. Okay, C. Find the probability that Sam removes a red disk on his first turn, given that Tom wins the game on his second turn. Okay, so because of the given that means this is conditional probability, which means now you need to count P. Sam remove the first disk. So Sam remove the first disk, given that Tom wins. Alright, so based on the definition of conditional probability, this is RS, and Tom wins over P Tom wins, okay, on his second turn. So now if the Tom wins in the second term, and the Sam removes the first disk, which means this is, okay, Sam removes the first red disk, the red disk on his first turn. Then Tom, because of the second turn, he is the winner, he is declared as the winner, means that first turn Tom must get red disk, okay. And then second turn of Sam cannot be red disk, otherwise he will be the winner, so it must be white disk for the second turn for the Sam, and Tom must be the red disk over P Tom wins. Alright, so now again here, so I will continue. Remember just now we have 5 white, 3 red. Okay, so initially 8, then 7, 6, 5. All these are the denominators. So red color will be 3 for the first. Second one also red color, means 2 left. Then the third one is a white, so it's 5 choices. Then the last one will be the red, 1 over P Tom wins. So this is the solution from previous part, which means it is 3 over 28. Okay, So you can simplify this by cancelling the terms first. This is here, I can simplify here, becomes 4. So now you will get 3 over 24 divided by 3 over 28. Okay, so wait, let me check. Okay, probably you can just count like this. If not, okay, I overlook it. This is basically no need to cancel with the 8. So 3 and 2 will be 6. So cancel. You get 1 over 56. That will be easier. So I will get 1 over 56 divided by, instead of 3 over 28, I can change to over the 56. So it will be 6 over 56. So cancel the 56. It will be 1 over 6. Alright, so this is the solution for this part C. Okay, so that's all for this video. Alright, so if you enjoy watching my video, please subscribe to my channel and stay tuned for more videos. Thank you. Bye.